Have you ever wondered what happens under the hood of your faithful vehicle? Buckle up, because today we're delving into the intriguing realm of how an automobile engine works. Your car's engine is like the beating heart of the vehicle. It's a powerhouse that converts fuel into motion, driving you down the road. But how does everything come together? Let us break it down. An automobile engine, also known as an internal combustion engine, is a device that uses the power produced by the combustion of fuel to generate motion. The main idea behind a car engine's operation is to transform the chemical energy stored in fuel into mechanical energy that can be used to propel the vehicle. The majority of cars today are powered by four-stroke internal combustion engines, commonly known as four-cycle engines, which generate power in a precise sequence. 1. Intake stroke. The engine cycle starts with the intake stroke. When the piston goes downward in the cylinder, the intake valve opens, allowing a mixture of air and fuel to enter the combustion chamber. This combination is essential for the combustion process that follows. 2. Compression stroke. Following the intake stroke, the intake valve closes and the piston returns to the top of the cylinder, compressing the air-fuel combination. This compression elevates the mixture's temperature and pressure, making it more volatile and ready to ignite. 3. Power stroke. When the piston reaches the top of its stroke, the spark plug ignites the compressed air-fuel mixture. The fast burning of the gasoline generates a high-pressure force that forces the piston back down, producing the power required to propel the vehicle. This is the stroke where the engine generates power. 4. Exhaust stroke. The cycle is finally completed with the exhaust stroke. As the piston rises again, the exhaust valve opens, allowing the burned gases to escape the combustion chamber and exit the exhaust system. This sets up the engine for the following intake stroke and completes the four-stroke cycle. These four strokes, intake, compression, power, and exhaust, are repeated in a continuous cycle as the engine runs, driving the vehicle forward by converting the energy released during combustion into mechanical motion. The coordinated movement of pistons, valves, and other components within the engine ensures that this cycle runs smoothly and efficiently to deliver the power needed for the car to operate. Key components of a car engine. 1. Pistons. Pistons are cylindrical components that move upward and downward within the engine's cylinders. They are joined to the crankshaft by connecting rods, which transport the force created by gasoline combustion to the crankshaft, converting it into rotational motion. 2. Cylinders. Cylinders are chambers where pistons travel up and down. Most automobile engines have several cylinders organized in a specific layout, such as inline, V-shape, or flat, to facilitate the combustion process and assure smooth operation. 3. Valves. Valves regulate the flow of air, fuel, and exhaust gases into and out of the combustion chamber. During the intake stroke, the air-fuel mixture enters the chamber, while the exhaust valve opens to remove the burned gases. 4. Spark plugs. Spark plugs are necessary to ignite the air-fuel mixture in the combustion chamber. They provide a spark that starts the combustion process, resulting in the rapid expansion of gases that drives the piston downward during the power stroke. 5. Crankshaft. The crankshaft converts the piston's reciprocating action into rotating motion, which powers the vehicle's wheels. It transmits the engine's power to the transmission and, eventually, to the wheels, propelling the automobile forward. 6. Camshaft. The camshaft coordinates the opening and closing of the valves with the movement of the pistons. It ensures that the valves open and close at the appropriate times during each stroke of the engine cycle, optimizing the flow of air, fuel, and exhaust gases to promote efficient combustion. 7. Connecting rods. Connecting rods connect the pistons to the crankshaft, transferring the linear motion of the pistons to the rotary motion of the crankshaft. They play a crucial role in converting the force generated by the combustion process into rotational motion to drive the vehicle. Engine lubrication and cooling. In addition to combustion, an automobile engine requires sufficient lubrication and cooling to function efficiently and avoid overheating. Here are some important components and systems involved in engine lubrication and cooling. 1. Engine oil. Engine oil lubricates the engine's working parts, which reduces friction and prevents wear and damage. It also helps to dissipate heat created during operation, allowing the engine to function smoothly. 2. Oil pan. The oil pan is placed at the bottom of the engine and contains the engine oil. It also houses the oil pickup tube, which pulls oil from the pan and circulates it throughout the engine to lubricate its moving parts. 3. Oil pump. The oil pump pressurizes and circulates engine oil throughout the engine, ensuring appropriate lubrication of all moving parts. It maintains the proper oil pressure to preserve the engine and assure peak performance. 4. Cooling system. The cooling system regulates engine temperature by removing excess heat generated during operation. It is normally made up of a radiator, water pump, thermostat, and coolant fluid, which flows around the engine to remove heat and keep operating temperatures within safe ranges. 5. Radiator, a heat exchanger that helps transport heat from the coolant fluid to the ambient air. It cools the hot coolant as it circulates through the radiator, letting it to return to the engine at a lower temperature and complete the cooling process. 6. Water pump. The water pump circulates coolant fluid through the engine and radiator to facilitate the transfer of heat and maintain a consistent operating temperature. It plays a crucial role in controlling engine temperature and preventing overheating. Engine control systems. Modern car engines are equipped with sophisticated control systems that monitor and regulate various parameters to optimize performance, efficiency, and emissions. These systems use sensors, actuators, and electronic control units to manage engine operation and ensure it meets regulatory standards. Here are some key engine control systems. 1. Fuel injection. Fuel injection systems deliver precise amounts of fuel into the combustion chamber based on signals from sensors that monitor engine conditions such as temperature, airflow, and throttle position. This technology enables more efficient combustion and better fuel economy compared to traditional carburetors. 2. Ignition system. The ignition system generates the spark required to ignite the air-fuel mixture in the combustion chamber. It employs sensors and control modules to modify the timing and intensity of the spark to ensure optimal combustion and engine performance. 3. Engine management system, EMS. The engine management system combines a variety of control tasks to regulate fuel flow, ignition timing, emissions, and other engine parameters. It continuously analyzes engine performance and modifies settings in real time to maximize efficiency and drivability. 4. Emissions control. Emissions control systems help to limit dangerous pollutants emitted by the engine, such as nitrogen oxides, NOx, carbon monoxide, CO, and hydrocarbons, HC. Catalytic converters, oxygen sensors, and exhaust gas recirculation, EGR systems are critical components for reducing emissions and complying with environmental requirements. Safety and maintenance. Safety and upkeep are critical when working on a car engine. Proper safeguards must be taken to protect the engine's lifetime as well as the safety of those working on it. When it comes to safety, there are numerous important factors to remember. 1. Personal protective equipment, PPE. When working on an automobile engine, always use the proper PPE, such as safety goggles, gloves, and hearing protection. This will keep you safe from potential threats such as oil splatters, sharp edges, and loud noises. 2. Engine cool down. Allow adequate time for the engine to cool before beginning any operation. Anyone working on a hot engine risks being burned. 3. Detach the battery. Before working on the engine, always detach the battery to avoid any electrical issues. This will also protect the vehicle's electronic components from damage. 4. Ventilation. Keep the workspace well ventilated to avoid the accumulation of toxic vapors from chemicals or exhaust gases. 5. Proper lighting. Always work in well-lit areas to minimize accidents or mistakes caused by poor visibility. 6. Fire safety. Keep a fire extinguisher available in case of an unforeseen fire. It's better to be ready than to be caught off guard. When it comes to maintenance of a car engine, regular upkeep is essential to ensure optimal performance and longevity. Here are some maintenance tips. 1. Regular oil changes. One of the most important maintenance duties for an automobile engine is to change the oil on a regular basis. This helps to lubricate the engine components and reduce wear and tear. 2. Check fluid levels. Make sure to check and replenish all necessary fluids, including coolant, brake fluid, power steering fluid, and transmission fluid. Low amounts can cause engine harm. 3. Inspect belts and hoses. Check belts and hoses on a regular basis for signs of wear or damage. Replace them as needed to avoid breakdowns. 5. Spark plug maintenance. Inspect and replace spark plugs at the specified intervals to guarantee optimum ignition and combustion in your engine. 6. Cooling system maintenance. To avoid engine damage and overheating, flush and replenish the cooling system on a regular basis. 7. Engine tune-up. To maintain the engine operating smoothly and efficiently, have it tuned up on a regular basis by a competent mechanic. 8. Listen to your engine. If you notice any unusual sounds or smells coming from the engine, address them promptly to prevent further damage. 9. Follow manufacturer recommendations. Always follow the manufacturer's recommended maintenance schedule for your specific vehicle to keep the engine in top condition. By following these safety and maintenance tips, you can ensure a safe working environment and keep your car engine in optimal condition for years to come. In conclusion, a car engine is a complex mechanical system that converts the energy stored in fuel into mechanical power to drive the vehicle. By understanding the fundamental principles of how a car engine works, as well as the key components, lubrication, cooling, control systems, and maintenance requirements, you can appreciate the intricate design and functionality of this essential automotive component. So there you have it, folks. A peek under the hood at how a car engine really works. Next time you're cruising down the highway, just remember all the magic happening beneath you. Alright, that's a wrap for today's video. If you enjoyed this breakdown of car engines, don't forget to hit that like button and subscribe for more awesome content. I'll catch you in the next one. Stay revved up, my friends.